Timecodes are the industry standard professional way to mark and sync video and audio data across devices. Cinema cameras and prosumer and professional audio recorders almost always support both timecode generation and the ability to sync to an external timecode signal. However, in the prosumer camera market, and even the professional camera market, especially even talking about cameras that are like $4,000 plus, native timecode support or sync is almost entirely absent. So in this video, I'm going to dig into how to work with industry standard timecode signals with our hybrid cameras. In this video, we're going to be looking at using external timecode with Canon's non-cinema hybrid cameras. Specifically, I'm going to be using the EOS R5 and R5 Mark II in this video. Now that said, while the demos in this video use both the R5 and R5 Mark II, the approaches that I'm going to cover work on any of Canon's EOS R series cameras. The only difference may be in the location of some of the menu settings. Now, since we're talking about consumer-level cameras here, it's entirely reasonable that you might be new to all of this and maybe asking, what the heck is timecode? And along with that, why should I even care about it? So, timecode is the standard way to address frames in your video or audio, essentially files. Now, when combined with synchronization or a synchronized distribution system, timecodes can be used to easily and accurately synchronize recordings from multiple cameras and audio recorders in post so that they all line up. In short, with a timecode system in place, you can shoot with multiple cameras or use two system audio and not have to worry about whether or not you'll be able to sync the footage in post. Now, of course, the next question is, why use it at all? I mean, after all, most modern NLEs support some form of audio sync, and of course, clapping at the start of your video and talking throughout it is, well, free. Now, a big part of the answer to that is reliability. Using timecode doesn't require every camera and recorder and microphone to be close enough that it can get a clean recording of the slate sound or anything else, meaning you can easily sync things that are shot on windy days or where one camera is far away from speakers or where you're recording audio that its built-in mic can't pick them up clearly. Now, a second reason is speed and accuracy. Devices that at least in devices that natively support timecode operations, they will write that timecode information directly into the files as they are recorded. As such, you don't need to do anything in post to use the timecode, it's already there. Now, unfortunately, Canon's consumer-level EOS R cameras don't have that capability. But that doesn't actually stop us from doing what we want to do with timecode. It just changes the process slightly. Now, that said, even though you'll still need to do some post-processing with these cameras, the process of the time it takes to process timecode data is almost always faster and vastly more reliable in terms of accuracy than just using audio sync in your editor. Oh, finally, one advantage that isn't talked about or thought of, I think, as frequently is that in post, having synchronized timecodes in your files means that you have the easy ability to realign tracks if they get moved out of sync on your timeline somehow. This is, of course, possible, but it is with non-timecode approaches, but it is something that's far easier to do when you're just looking at a time and putting the times back in line. Now, with that said, there are three different timecode implementations that cameras use and deal with. These are the embedded timecode in our video files, the HDMI timecode, and the SMPTE, or Society of Motion Picture and Television Engineers, linear timecode standard, and we're kind of going to have to touch on all of them. Now, regardless of whether you mean to or not, every file that your camera records video-wise has timecode data embedded in it. This is an inherent part of just how these cameras operate. The timecode information is written using Apple's QuickTime timecode standard and is written into your video files as a separate track, a timecode track, that your nonlinear editing software can read and understand. Now, similar to the video files, the cameras can also output its internally generated timecode, which is where it gets it for the video files, over the HDMI port to a downstream device. Now, that said, the HDMI timecode can be read and used by some camera-oriented HDMI devices that are targeted in this market segment. Now, if you're really interested in extracting it and using it however you want, you actually can do that. It is a bit costly, but you have to convert the signal from HDMI to SDI using something like a Blackmagic Design HDMI to SDI converter, and then extract the standard SMPTE linear timecode signal from that SDI signal using something like a Blackmagic Design Terranex Mini SDI to Audio 12G device. That will get you there. With that said, the HDMI timecode can also be used directly by some devices. One example is Atomos's lines of monitor recorder field monitors, or however you want to phrase it. They can read the HDMI timecode from Canon cameras and sync their own internal timecode to it. In addition to synchronization, they can also use the timecode as well as a start-stop signal to start and stop recording, so you can trigger their recording by sending timecode information, vice versa. Now, similarly, Sound Design's line of MixPre 2 audio recorders, or at least the MixPre 6 and MixPre 3, can also take an HDMI timecode signal through a micro HDMI connector and apply that to their recordings. And like the Atomos monitors, these recorders can be set up to automatically start and stop recording based on the state of the timecode input. That said, without a simple way to strip the timecode from an HDMI signal and export it in a standard foam, HDMI timecode is really not all that broadly useful for most devices, at least not if, as I said at the beginning, unless you want to spend, several $100s to get there. Now, while both the QuickTime and HDMI timecodes are both generated in the camera, the Society of Motion Picture Television Engineers, or SMPTE, linear timecode is not. Linear timecode is the industry standard way to share timing information across devices, and this is what you will want to use when you synchronize, or will be using when you synchronize multiple devices normally. Now, if you're interested in the ins and outs of the SMPTE and linear timecode standards, I have done a more in-depth video on them, which I will link in all of the usual places that you can go check out. Now, when the SMPTE designed the linear timecode system, they were really smart about it. The linear timecode signal is a digital bit stream, but it is done or set at a slow enough bit rate and modulated in a way that can make it, or that allows it to be processed either directly by compatible devices, or for devices without native support, it can be recorded as an audio signal that can be interpreted or processed after the fact. Now, unfortunately, Canon's consumer-level cameras don't natively support linear timecode, so we have to take advantage of the audio recording method with these cameras to get synchronized footage in post. Now, Canon's Hybrid EOS R cameras have an entire timecode menu when you are in movie mode. If you're interested in a detailed look at those settings specifically, I did a video on that almost a year ago, and again, I will link that in all of the usual places. However, for what we're doing today, none of those settings matter. Unfortunately, the reality of Canon's hybrid cameras is that they're not designed to work with standard LTTC timecode signals internally. This means that anything we want to do with these cameras from a timecode perspective, we have to simply just record the linear timecode signal as audio and process it after the fact, which means for us today, we're actually more interested in the audio recording settings and how to configure them than we are with the timecode related settings. So let's talk about the nuts and bolts here of dealing with an external timecode source. Of course, we need an external timecode source of some kind to do this. Now in this video, I'm going to switch through a number of linear timecode generators as well to produce this signal, as the reality is it's not really important to what is producing it, just that we have one to work with. At one point or another, you'll see me using either a Deity TC1 timecode box, a Zoom F6 audio recorder, or a Canon R5C Cinema EOS camera. Though, like I said, you could just as easily use Tentacle sync boxes, Sound Device Mix Pre 2 audio recorders, some Tascam audio recorders like the FR-AV2, FR-AV4, and HSP-82 all support timecode output, among other devices from other brands. So, with that in mind, let's look at what we have to do to get this all working. Now, the big picture here is actually quite simple. We feed the linear timecode signal into the mic port of our camera, and we adjust the timecode generator and camera settings so that we get a useful recording. Now, with that said, I am going to make one big deviation here from what most guides that talk about timecode will tell you about adjusting your camera's levels. The LTC timecode signal, while being low enough frequency that it can be treated as audio, is not an audio signal. Most guides you'll find will talk about recording LTC with either the mic or line-in terminal, will tell you to adjust the levels so that the LTC timecode stream is a middle loudness so that it doesn't clip. Digital clipping does not affect the LTC timecode signal. The signal itself uses something called biphase mark or differential Manchester encoding. This allows both the clock rate and the data to be encoded in the signal that is resistant to both noise and supports easy clock and data recovery. What makes biphase mark encoding work isn't the data levels that you have, it's how the timing of transitions happens. That is, it does not use a level, like a high level to indicate a 0 or a 1 and a low level to indicate a 0. It uses whether or not a transition happens in the middle of a clock period. A biphase mark signal changes from high to low and vice versa every clock cycle. In the linear timecode implementation, logical zeros are then encoded with no additional transition during that normal clock cycle. So it's just a long period and then it transitions to the next state. Logical ones are encoded as a transition at the midpoint of the clock cycle. So get halfway, transition, get to the end, transition to the next state. In this system, phase doesn't matter. A 0 can either be full positive voltage or full negative voltage as long as there isn't a transition halfway through the clock signal or clock period, it's a 0. The result of all of this is a signal whose waveform looks like a square wave that looks something like this. Now, why doesn't clipping affect the LTC bit stream? Because a clipped square wave is still just a square wave. The transitions are what matters, and clipping doesn't affect where and when the level transitions happen. Now, that said, if you happen to be using an analog recorder, distortion could potentially affect your results, and you may need to be careful about that. However, our digital cameras don't do analog or aren't analog recorders, and neither are most of the external field recorders that we'd be working with, so none of that matters. The only real concern is signal voltage, and I only barely mean to bring this up because even here it's not that big of a deal. That is, if you're feeding a line level signal into a true mic level input, could you potentially damage the mic level input because you're sending a too high of a voltage signal? Here's the deal. In theory, yes. However, virtually every camera on the market, and certainly all of Canon's cameras, can deal with a much wider range of input levels on their mic ports than a pure, true mic level signal. Even if they don't expressly have a line level mode, you're not going to damage the camera feeding it a line level LTC signal. Okay, with that said, let's start with the whole, we've got a line level LTC signal, since that's what the standard for linear time code is, and what can we do and how do we deal with this? Now, on the Canon R5 and similar cameras, these are any of the cameras that Canon makes that only support 2-channel audio recording. There are a couple of considerations that we have to deal with. Of course, you could just plug the line level LTC signal right into the mic input port, shoot, and you absolutely should not have a problem recovering the time code after the fact as long as audio recording is turned on in some form. I mean, in some ways it really is that simple. However, if you want to be a little nicer to your mic amp or camera's mic preamps, you can, on these cameras, turn on the -20 dB attenuator. Now, this is not going to bring a linear or a line level signal down under the mic clipping point, at least if the gain's cranked up. But that combined with knocking the gain or level down will bring you down under the digital clipping point, and that's going to probably be good enough for making things happy, or at least making users happy, because the camera probably really doesn't care. The real consideration with these cameras is that because they only have 2-channel recording, when you plug an external source into the mic port, they disable the built-in microphone. As a result, you will get a linear timecode track on these cameras, but no scratch audio, which might actually be kind of important. Now, if you want both timecode and scratch audio, you will also need an external mic and a stereo to dual mono adapter cable. At least this is assuming you're not using something like Now, since we're not combining 2 signals together, one's going to the right channel, one's going to the left channel, we don't need to worry about mixers or anything like that, where we could just use a straight stereo to two dual mono, left mono, right mono Y cable for this. Plug the breakout cable into the mic port, plug your timecode signal into one of the inputs, plug the mic or your mic's input into the other one, and now you have scratch audio and a timecode track on a 2-channel only Canon camera. However, keep in mind, with a line level timecode signal and a mic on a Y cable, you will not be able to use auto gain control to control recording levels. The linear timecode signal will absolutely overwhelm it, and your mic won't get you anywhere. So you will need to use manual gain control for this. On top of that, when setting the levels, you're going to want to focus on the channel that the mic is using, not the timecode channel. And you want to adjust your mic levels as you normally would, so between -18 and 12 dB full scale. The timecode channel may clip. That's fine. Also note, if you're using the Canon camera's built-in attenuator to bring down the timecode signal from full linear or full line level, you probably will want to use a mic that can boost its output, something like a Rode VideoMic Pro or a similar product that lets you push the mic up the 10 or 20 dB to compensate, or alternatively, you'll want to get and use an inline attenuator on the linear timecode signal to get the mic levels so that you actually can kind of work with things reasonably, or just don't use the attenuator in the camera. Now, on Canon's more modern cameras, this is going to be the R1, the R5 Mark II, the R6 Mark III, the R6V, and the R50V, at least as I'm recording this. All of these cameras are capable of recording 4-channel linear PCM audio. When in the 4-channel mode, these cameras will continue to record scratch audio using the built-in microphone, in addition to recording whatever is being put in on the microphone in port. Moreover, both the built-in mic and the mic port levels are controlled separately, so you have a way to deal with this all in all from a more granular perspective. 4-channel recording is enabled by setting the audio format setting on page 2 or the sound record settings page of the red shooting menu section to LPCM/24-bit/4-channel. Now that said, these cameras no longer have a 20 dB attenuator, so that's just not an option anymore anyway. Now, another alternative, or the other alternative for all of this, is to use a mic level timecode system. Specifically, timecode generators like the Deity TC1s and the Tentacle SyncEs both support outputting the linear timecode data stream at mic levels instead of line levels. Now, this gets us around the whole clipping problem that really isn't that much of a problem, but more importantly, both the TC1 and the SyncE have a microphone on them that you can use to create a scratch audio track in addition to the timecode track that they output. So if you are using these devices, which honestly is a better solution than a line level LTC signal if you can swing it, well, really, this is just an integrated version of what I described for the line level LTC track, just without the extra hoops of having a Y cable, possibly an external attenuator, and all of that, and an extra microphone. You just have your little timecode box, and it does its thing. Now, in this configuration, I would still recommend setting your camera's levels manually and adjusting them based on the mic channel, not the timecode channel. But in this case, linear or using auto levels may actually work in some cases, especially if you expect loud ambient noises or loud noises that you don't want to clip. So that about covers the extent of what you can do with an external timecode generator when working with Canon's standard hybrid EOS R cameras. Though honestly, none of this is really that specific to Canon's cameras, as these approaches work with any camera that supports an audio in and doesn't have a timecode port. Now, with that said, if there was one thing I would love to see Canon do, is support at least receiving a timecode signal natively instead of having to do this whole audio process. The cameras already have a mic in. They already have the processing capability to support dealing with this. Granted, they don't have the ability to output reasonably to output a generated LTC signal, but you know what? These are not cinema cameras, and I'm fine with that. On these cameras at sort of their price point, but it would really be nice to be able to plug a LTC data stream into the mic port, tell the camera the mic port is timecode, have it use this internal mic. Well, I mean, it's not really an issue with the newer cameras, but and then have it sync up to that external timecode and have that just natively put in our videos. Now, again, I get product differentiation, market segmentation, and all that good stuff, but at least half of an implementation that gets you somewhat accurate results is better than no implementation at all that requires kludgy workarounds. That said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. Also, if this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. Finally, if you'd like to help and support this channel, you can help us for free by liking this video, sharing it with your friends, and leaving a comment with your experiences. Likewise, you can support us by hitting that thanks button or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.